For this video, it's going to be the entire lesson of complex numbers number 2. We're going to cover a little bit more today, going a little bit more in depth with our complex numbers. This is going to end the number of lessons for complex numbers. This will be the last one here. What I wanted to cover in this video, and it's going to be a little bit more of a lengthy one because I'm going to cover the entire lesson, but what I want to cover is dividing imaginary numbers. We're going to also be graphing complex numbers and solving quadratic equations, in which sometimes you'll get an imaginary number pop in if you've ever plugged it in the quadratic equation and came up with this square root of negative something. That is an imaginary number. We're going to show you how to work with those today. Now on this one, we did this one in Algebra 1, and with this we can't have this radical on the bottom. So the way that we get out of that, we call that rationalizing the denominator. The way we get around that is we multiply top and bottom by whatever this amount is, the square root of 5 in this case. So I'm going to multiply top and bottom by the square root of 5, okay? So here's my original one. I just multiplied top and bottom by square root of 5. So 3 times the square root of 5 is 3 square root of 5. Square root of 5 times square root of 5 is square root of 25, which is 5. So this one's done. What I've basically done is taken this rational, gotten rid of it out from underneath the bottom, and moved it up to the top, essentially. But I did that by multiplying top and bottom by the square root of 5. Now, really, we did not change its value because we multiplied top and bottom by 1. I have the square root of 5 over the square root of 5, which is 1. So we haven't changed any of the value. All we basically did was get rid of this radical on the denominator. And any way possible, in this case, it ended up moving it up to the top. Now let's go over one that's an imaginary number. Along those same lines, we can't have this imaginary number on the bottom. A couple different ways we can do it. Really, we have to remember that this imaginary number is basically the same thing as the square root. Okay, it's a square root of negative 1. Now, we can't have this square root on the bottom as well. Okay, so it kind of follows the same path here. So instead, we're going to take this one here and we're going to multiply top and bottom by something to get rid of this I. Okay, remember there's our I. We're going to multiply top and bottom by I, because I know that I times I is I squared, and I know that I squared is negative 1. That's no longer a square root sign, okay? So that's the easiest way, in my opinion, to do it. I'm going to show you two different ways, but okay, so if I multiply the top, 2 times I gives me 2I. 3I times I gives me 3I squared. Well, I know that I squared is negative 1. So now I multiply negative 1 times 3, and I end up with negative 3. So I've got 2I over negative 3. You'll see it written a couple different ways. We could have had negative 2I over positive 3. That's equivalent, okay? That's the same thing. Now here's how most students want to do it. This will work. It's an extra step. I don't like this one because it's a little bit more prone to error. It takes a little bit longer. If I multiply, this is the same one here that I have in purple. If I multiply top and bottom by whatever this denominator is, this 3I, a lot of students want to do that, and that's fine. It will work. It takes a little bit more effort, though. If we do that, 2 times 3I gives me 6I. 3I times 3I gives me 9I squared. Okay, well we know I squared is negative 1. Similar to what we did up here, I squared is negative 1. That's going to give me 6I over negative 9. Well, now we have to reduce, and this is the part that, the reason why I don't like this one is because later we're going to have to reduce. So now I have to reduce. 6 and 9 is the same thing as 2/3. So you notice these two answers here, this one and this one up here, are exactly the same. So either process that you do is okay. I find it to be much easier if I just multiply top and bottom by I. Just whatever I'm trying to get rid of. I'm trying to get rid of this I, so I multiply top and bottom by that quantity, okay? All right, now let's have you try some. I want you to try these two. So go ahead and push pause on the video now. You can work through your answer. After you've obtained your answer, come back and push play. Check your answers here. Okay, hopefully. Now once you get your I squared here, this is the big thing. Make sure you have a negative 1. Now you could have had this one written as negative out here, 4I over 5. That's fine too. This one over here, same thing. The biggest thing that I want you to be aware of on this particular one is we multiply top and bottom by I. These are two separate quantities. This I squared here is negative 1. Now, when you do that, you end up with this one here. However, it must be written in the correct order. In other words, we've got to have this negative 3 way out in front. So it's got to be negative 3 plus 2I all over 7. Okay, it's got to be written in the correct order. All right, now we're going to get into division of complex numbers. I don't spend a lot of time with the simpler one, only because if you go back to that one, you're just multiplying top and bottom by that I. Let's get a little bit more time and in depth into this one. This is really the same thing as 8I over 1 plus 3I. Okay, so now I still have this I on the denominator. We can't have that. So the way that we're going to get rid of that, and this is going to be a little bit more complex, is we're going to multiply it by something called its complex conjugate. That's a very big term. All that really means is my goal here is to get rid of this I. The way that I can do that is I multiply this bottom by almost itself. Okay, on the denominator here I have a 1 plus 3I. I'm going to multiply that by 1 minus 3I. So let's talk about this just for a second. The goal is to get rid of these i's. Well, I know one time, if I multiply these two together now, assuming there's some parentheses here, I can multiply this. 1 times 1 gives me 1. No problem there, no i's there. 1 times negative 3i is negative 3i. Then I'm going to go 1 times 3i gives me positive 3i. So those i's are going to cancel. Finally, I'll have a 3i times negative 3i, which would be negative 9i squared. Remember, I squared we can get rid of. Okay, so, and I kind of went through that fairly quick, but the biggest thing is here, whatever this sign is, we're going to change it. Right here it was an addition sign, so I changed it to a subtraction. If it was a subtraction sign, I'm going to change it to an addition sign. Doesn't really matter. Okay, and then I'm going to multiply the top. Now this hopefully makes it a little bit easier to read. Notice I used parentheses here because it's not 8i times 1. It's 8i times this entire quantity. Now this one here, for those of you who are familiar with foiling, that's what we're going to do here. As you foil these, you'll notice that the i's will disappear. We'll have a negative 3i and a positive 3i. Those two will cancel each other. Up top here I've got an 8i times 1 is 8i. 8i times negative 3i is negative 24i squared. Okay, so we end up with this, and that's after we FOIL this one here, I end up with this quantity here. Now I've got an I squared on top and bottom. We know what I squared is. I squared equals negative 1. So now I can simplify both of these. Okay, so we've got negative 24 times negative 1 gives me a positive 24. Negative 9 times negative 1 gives me a positive 9. So this gives me 8i plus 24, and here it gives me 10. Okay, 1 plus 9 gives me 10. Now I look here and I say, okay, what can go into all three of these numbers? 8i, 24, and 10. Well, 2 can go into all of those. So that would leave me 4i, 6, and 5. Okay. Okay, so I've got these here. Now I have to put these in the correct order. So I've got to go this 24 needs to come before the 8i. Okay, remember our real number comes before our imaginary number, so I'm going to write that there. Now that I've got here, I've got 24 plus 8i all over 10. I look at these three numbers and try to determine if there's a number that goes into all three of them. I notice that a 2 will go into all three of them. So what I'm going to do is divide each one of these by 2. And if I divide each one of them by 2, I end up with 12 plus 4i all over 5. This is my final answer. It must be written in the correct order, 12 plus 4i. Remember that your imaginary component comes second. And there's quite a bit to that. So I'm going to give you a chance to practice a little bit here. So here are 2 of them that I have, and I'm going to give you a little hint on this first one. This first one here, you're multiplying it by its complex conjugate. Remember, that's a fancy term for basically writing the same thing here, but we're changing the sign. So you should multiply top and bottom here by 1 minus 10i. Okay, go ahead and try these 2. Push pause now. Work through them. After you've obtained your answer, come back and push play. Check your answer on this first one here. I didn't give you both because I want to just kind of go through this one real quick. Okay, so I times 1 gives me 1i, or just I. Remember, we don't write the 1 in front of it. I times negative 10i gives me negative 10i squared. Remember that our I squared, that's good because we know what I squared is. That's a negative 1. That's how we get rid of this on the bottom here. And again, I got these 2 numbers here by foiling this. 1 times 1 gives me 1. 1 times negative 10i is negative 10i. 1 times 10i gives me just positive 10i. So those 2 will cancel. That's why they're not here. And then 10i times negative 10i gives me negative 100i squared. Okay, now go ahead and finish number 2 if you haven't. And then push play whenever you're done. Check your answer here. Okay, again on this one, we want to make sure that we write these in the correct order. We did that as well over here. But the real number comes first, then the imaginary component afterward. And this one, it looked like we had something that went into all three of these. We had a 2 that went into all three. So we take out our 2, that leaves us negative 10, and then take a 2 out of 4i gives me 2i, 2 out of 26 gives me 13. Okay, I want you to try these two. Go ahead and push pause now. After you've obtained your answer, come back and push play. Check your answers here. Hopefully you obtained this, and now on this one it really doesn't matter if you wrote 2 plus 8i all over negative 3, or if you wrote negative 2 minus 8i all over positive 3. It really doesn't matter. On this one, instead of writing the negative on the denominator, you could have written it up top, but it must apply to everything up top, so that means it changed both signs here. On the second one over here, we just need to make sure that we write these in the correct order. So that's why I looked at the 70, 14, and 104. Notice a 2 went into both, or all three of those. And then I just wrote it in the correct order, 35 plus 7i all over 52. Okay, I want you to try these two now. Push pause on the video now. After you've obtained your answer, come back and push play. Check your answers here. Hopefully you're starting to kind of get the hang of this just a little bit now. Okay, now let's get into graphing these complex numbers. Again, just to review, we have a real part and an imaginary part as a complex number. So when we're graphing these, we've got a new plane, and this kind of looks like our xy coordinate. This is the real axis. Previously, this has been our x-axis. Now this is going to be our real axis. So that would make this one, instead of our y-axis, this is going to be our imaginary axis. All right, so we've got our coordinate here, our graphing plane, the complex plane. So we've got this one. This is our real part. And real, remember, if we were graphing x's and y's, the x's come first, then the y's. This is a similar process. The real part comes first. That means it's negative 2. Positive 5i means that we're going to go up to 5i. And we'll put a little dot right there. Okay, this one here, I've got a positive 2. Means I'm going to go right here, and positive 2i. That means we're going to go somewhere right around here. All right, I want you to graph this one. Go ahead and push pause now after you've graphed it, then come back and push play. Check your answer here. Hopefully you got that one right. This one here I'd like you to graph as well. Remember, we're graphing the real part first. That means we're going to go on our x-axis first. Then we're going to graph the imaginary part. Okay, go ahead and push pause now, and then after you've graphed it, come back and push play. Check your answer. Now I'm going to give you one that just looks a little bit different than those. We've got the same complex plane coming in here. I want you to graph this one. This one's a little bit more challenging. There is no real number here. There's only an imaginary component, so we're not going to go left or right for our real numbers. It's just going to be the imaginary line that we're going to graph it on. That's it. It's equivalent of like 0 minus 2i. Okay? And then 3, of course, that one does not have an imaginary component, so we're just going to go 3 in the positive direction here. It does not go up or down on the imaginary line at all. All right. Now I want you to solve both of these. We've kind of done these before, so these should be somewhat familiar to you. I'll give you a hint. The first one comes out with a real number. The second one ends up being an imaginary number. Okay, push pause now and try to obtain both answers, then come back and push play. Check your answers here. Remember, it should be plus or minus. It can be either one, okay? From here, I could have either a positive 4i or a negative 4i. It really doesn't matter because we're going to be squaring it. Okay, same thing, same process that we did over here. Either way is okay. All right. So now let's go in here. Let's see here. I want you to solve both of these. Push pause on the video now. After you've obtained your answers, come back and push play. Now these became a little bit more tricky only because now I've got this 10. It's not a perfect square. So when you take the square root of both sides, then I get the square root of negative 10. Well, we know what the square root of negative 10 is. That is I square root 10. We learned that in our previous lesson. If you need help on that, go back and review that previous lesson there. So, and similarly on this one, we just had a perfect square in here. We had 4 that we could pull out as well as an I. We pull out the 4, that becomes a 2 on the outside. All right, now let's work on this one a little bit. This is a quadratic, just similar to the ones that we previously did, only this one has a linear term. It's got this 2x in the middle of it. So if we're going to solve this one, I need to get everything onto one side. So I'm going to subtract 2x from both sides. That gives me 2x squared minus 2x. Remember, we cannot combine these two because this one's a squared, this one's just to the first power. Now I've got to get my negative 1 on the other side. That means I'm going to add 1 to both sides. I end up with this one here. Unfortunately, this one cannot be factored very easily. So I'm going to have to plug this one into the quadratic formula. Well, the quadratic formula, I have to find out my a, b, and c values. There's my quadratic formula. My a value is 2, and that's this number out in front. The b value is negative 2, that's the one in front of just the linear term, the x term. And then c is my constant, that's the one that's just the number. Now I'm going to take this and plug this into this quadratic formula. You've done this before. So the quadratic formula should not be new there. As I'm plugging them in, here I have negative 2 squared, which is positive 4, minus 8 it looks like here, and on the bottom here 2 times 2 is 4. Okay, so I'm making a little bit more progress here. I've got 4 minus 8, which is negative 4. So now we have this square root of negative something under here. Well, we know what the square root of negative 4 is. That's an imaginary number, so that's the equivalent of 2i. Okay, so now I've got 2 plus or minus 2i all over 4. Right here I look for a number that will go into all 3 of these. If a number does go into all 3, then I can reduce it. In this case, a 2 goes into all 3. So I'm going to take a 2 out of each one of them. I'm going to divide each one of them by 2. That will reduce me even further. My answer here should be 1 plus or minus I all over 2. Should be 1 plus or minus 1i, but we don't write the 1 in front. That's similar to a variable there. Okay, so we're going to use that same process now. I'm going to have you work on 2 of them here. I want you to work on these 2 right here. We're going to use the same process as the previous one, so if you need to, you can go back in and rewind the video just a little bit to see what I did there. Check your answers here. On this first one here that you did not have to reduce this one at all. That kind of made it a little bit nice. We just have the I is all we have to do. We have to take the I outside of that radical, which we did, and that was fine. The second one you did end up having to reduce this, which is fine. We use the same process that we were doing with quadratics. With the traditional quadratic formula. The only difference is now we've got an imaginary number here, and that's it. Other than that, it's the same thing we've been doing. Okay, last 2 here, and then this will conclude our video. I want you to work through both of these 2. After you've obtained your answers, come back and push play. Check your answers here. Okay, the first one was a little bit easier only because we did not have to reduce anything. The second one is negative 2, 2i, and 8. 2 comes out of all of those. That's where my 2 came out. So hopefully you're kind of getting a grasp of this. This will conclude the video, and this will conclude our section on complex numbers as well.